I am Professor Cabbage. It is my duty to show you some things about cold temperatures. Liquid nitrogen is almost 400 degrees below room temperature. When things get cold, they change their properties. Typically, they shrink. Pretty crazy, right? What I'm going to do is put some liquid nitrogen in this beaker and put this balloon in the beaker, and we'll observe any changes. So what is this liquid nitrogen stuff? Well, it's colorless and odorless. It's non-toxic and non-flammable. And above all, it's very cold. Its friends call it liquid air. Those are some of its vital details, but why does it act the way it does? Let's start with the reason why liquid nitrogen is called liquid air. I think it makes sense. The air we breathe is mostly nitrogen. In fact, it's 80% nitrogen. There's 20% oxygen, and that's the part you really need when you breathe. So if you convert that to a liquid, then why not call it liquid air? But what happens when you convert a liquid to a gas? Like when you boil a pot of water. It bubbles and steams, right? Kind of the same thing is happening here with the liquid nitrogen, only it doesn't need to be at 100 degrees Celsius like water does to boil. It's boiling at 400 degrees below zero, but it's boiling because it's surrounded by a toasty hot room. So you see we have boiling liquid nitrogen, and above it is a fog. Now when you look at boiling water, you see a kind of fog. In fact, that's steam, which comes off of the boiling water. When liquid nitrogen boils, what comes off of it is cold nitrogen gas. That cold gas causes water in the air to condense and to form a fog. Okay, cool, swell, groovy, great. How does the liquid nitrogen make it shrink like that? Well, in its normal state, there are zillions of molecules inside the balloon bouncing around every which way and basically going nuts. This creates enough pressure to match that of the atmosphere. But the liquid nitrogen makes the air inside colder. It slows down the movement of all those molecules and reduces the pressure, which is about as close as they will ever get to taking a vacation. While they are relaxing, the atmosphere takes advantage and makes the balloon contract. Heat conduction is what happens when a hot object touches a cold object and thermal energy passes from the hot object into the colder one. If you're ever super cold, then just go and hug somebody who's warmer. They may hate it because it's making them colder, but you should warm up in a jiffy. Same thing with a balloon. When that cold balloon is taken out of the liquid nitrogen, it's put on the warm table and it's surrounded by warm air. So heat is conducted from the warm air into the balloon, and it speeds up the molecules inside, raising the pressure and making the balloon expand to its regular size again. That's all well and good, you may say, but when is there ever going to be a balloon shrinking emergency in my life? What's the point? Good question. Liquid nitrogen, it turns out, has all kinds of real-world uses. It can be used to freeze lesions and warts that might otherwise become cancerous. You can use it to make ammonia for fertilizers. And, most importantly of all, you can make ice cream. And who knows, maybe those bodies that have been frozen with liquid nitrogen will be brought back to life one day. Although, I don't look forward to having to explain the Hannah Montana movie to Walt Disney.